Hi, everybody in Research Methods, Psych 290. This is section 13 of the reading packet, and this will get you ready for the next exam, which is exam number 4. I'd like to say that this chapter or this section is important for your paper as well as for the next exam, but that wouldn't be true. The reason why is very few of you are going to do an experiment. In fact, I highly discourage it. I would encourage you to stick with what we already have discussed, doing a survey, and then doing a very simple correlation t-test, one of each, or two of one, or two of the other, because doing an experiment is a lot more work, but we still need to cover it. This is a research methods class. It needs to be talked about, and you will need to know this for the exam. Now, what you will see here on this next page is slightly different than what is in your reading packet. The reason why is because if we were sitting in class together, I would make this more of a discussion and a project, and where you would be able to learn from each other. So what I did here is literally a cut and paste. We think of that in technology terms usually, but what I did here was actually typed it out on Microsoft Word and then just pasted the little strips in place. So my apologies, it isn't very pretty. What is an experiment? It's the only kind of research where you are making something happen. You are forcing change. You are causing something to happen, any way that you want to word it. So, how is this different? Well, when you do a t-test, which I think most of you are doing for your paper in this class, you would simply get people to fill out a survey, and then you would compare males to females, children to adults, people with jobs versus people without, full-time students to part-time students. That would be examples of independent t-tests. Or correlation. How is your survey score related to your age? How is your survey score related to the number of hours you work every week? Those would be correlations. One group with two number scores. But an experiment is different, because in an experiment you are causing something to happen. So let's use the example you will see here. I have two different groups of people, maybe. I know it sounds like an independent t-test, but it's not, because I am going to force them to take medicine for their headaches. They signed up, so hopefully they'll do what I ask them to do if this is that kind of medical study. So let's use that as an example. A new medicine for headaches. The independent variable. What is different from group to group? What is manipulated or changed? Well, in this case, it's the introduction of medicine. Maybe you just lay down and take a rest or put a washcloth on your forehead or something. No, we're going to have people take medicine. And the introduction of medicine is the independent variable. What is the dependent variable? That is what we're going to study at the end of this research project. I want to see if symptoms went down. Reduction in symptoms. That would be the dependent variable. What is the outcome variable? The outcome measure, or what are we measuring at the end? Now, all good studies, or almost all I should say, have a control group. There are a few exceptions when maybe you wouldn't want to do a control group. So, oh my goodness, let me get this back to normal. You can see I'm still learning this program. Okay, control group. What are we talking about there? You have one group of people in most research studies who get nothing. What does that mean? It could mean three things, actually. They could literally get nothing. You give them no medicine for their headache. That's kind of mean and cruel, isn't it? How long would your headache last if you don't have any medicine to take? A second possibility is a placebo. I bet almost all of you have heard of that. A fake medicine. What if we crushed up a Flintstones vitamin? Remember those? And we put it in a pill or a capsule, and you thought it was headache medicine. Is it mind over matter that you believed it would work? Well, that's a placebo. The third possibility, where you're still giving people none of the independent variable, is called business as usual. What do you usually do when you get a headache? Take an Advil? Okay, just keep doing what you normally do. That's another way of giving people nothing because they're not getting the independent variable. So they either get nothing, they take a placebo, or they do business as usual. You just tell them to do what they normally do. Experimental group. This is the, oh, there I did it again. Messed up, same mistake. Let me pull the pencil down. Do it the right way. There we go. The experimental group. This is the group that gets the independent variable. So in this case, they would get the medicine. Now, let's move down and talk about error and the experiment. That's the name of this section, isn't it? Extraneous variable. Think of the first 5 letters. Extra. Something that you didn't anticipate before the study even started. Unforeseen things. For example, I had no idea that almost everybody who signed up for my study would be male and not female. That really changes things. Might even ruin my results. I had that happen once when I did a study on campus. I was working with the vice president, and we were asking students about their involvement on campus, and like nobody returned the email. So instead, we put up posters and said, pizza and drinks. Guess what? It was almost all guys who showed up that day. We were happy that finally some people wanted to fill out our survey, but out of the 15 people who came, I think like 13 of them were male. That kind of thing can happen. Unforeseen things that are present before you ever even start. Confounding. This is different. What if something happens during your experiment? If you're doing a 5-minute experiment, it's less likely to happen than if you're doing a 6-month experiment. These confounding variables are almost certain to happen. Like what? Well, people's headaches are affected by the weather. So if you have people drive down to get their medicine or their placebo, what if it's a terrible monsoon and there's dust in the air and, oh my goodness, that can really mess with your headache, don't you think? Confounding variable. Something happens during the study. So let's go over all 6 of these again with a different example. How about tutoring? You're getting tutoring for your really hard math class. The independent variable. Some people are going to get tutoring. Hopefully randomly we pick them. We don't let them choose. And the other group does not get any tutoring. Well, the independent variable is the tutoring. The dependent variable. What are we going to measure at the end of the study? Well, probably their final score in math, don't you think? How well did they do for the semester? That's the outcome measure. Control group. There are 3 ways of doing this, but only 2 make sense here. 1, you could get a group and give them no tutoring. Placebo. I don't know how to do placebo tutoring. That doesn't really make sense to me. But business as usual? Absolutely. You could tell people, just do what you normally do. You have your own tutor? Great. You do study groups? That's fine too. You do something online? Well, that's your business. Business as usual. You tell them not to change their normal routine. And the experimental group, they get assigned a tutor because they get the independent variable. Extraneous variables. What if a whole bunch of people who volunteer to be part of the study, they don't know which group they're going to be in, they're all honor students, they're all friends with each other, they are all a certain race or ethnicity, you don't know what's going to happen, extra things appear before your study even starts. And what about confounding variables in this example? Well, what if there's a pandemic like the coronavirus and tutors can't meet with people, so it's all done over Zoom now? That changed things, huh? If the study was done during a semester that something like that happened. That's real life. Things like that do happen? So, one more quick example, because this is not going to be a very long video. Dieting. The independent variable would be the diet, whether you get it or not. The dependent variable, how much weight loss happened between the two groups. The control group, they either get no diet, placebo diet, that sounds kind of weird, huh? That probably wouldn't happen. But business as usual? Yeah, keep eating what you normally eat. Either that or you tell the group they get nothing, they get no diet. It's not like they're going to get no food for 6 months, but they might get no diet. Experimental group, they get this new diet that we are going to try out on people. Extraneous variables, I didn't anticipate that the surveys would be given out at a gym and almost everybody who signs up is a member of the same gym. Wow, that really ruined my study, didn't it? It created error. Or a confounding variable, something happened during the study, such as there was a food poisoning case in the university's cafeteria. Oh my goodness, that changes everything because so many of my students went to the same university maybe and ate at the same place. See, that would change everything. Moving right along, experimental designs. Maybe I can make this a little smaller to get all of them in there at the same time. Maybe not. Okay, let me do it a little bit smaller than that for you. There we go. This is for people with good vision, isn't it? So, let's go through these. Oh my goodness, there's another staple hole punch there, huh? 3-hole punch, I should say, right where we are going to be looking, but that's okay. Different ways of doing an experiment. It goes from the least to the most scientific, or in other words, the most amount of error, and then the least amount of error. So let's go through these. First, single group, post-test only. You saw probably I got a social media notification. We're going to ignore that. Single group, post-test only. You have one, hopefully randomly picked, group of people. But wait a minute, that R probably shouldn't be there. Let's get rid of that. Put a line through it, because otherwise it's exactly the same as the next one. You have one pre-existing group of people. Their observation, there is no pretest, but you still do an intervention with them, like people at a hospital or a university, you give them a diet and you measure them afterwards. Now, the second one, what if it is random? You can randomly get 100 people, let's say. You do no before testing, but you still do the intervention. You give them a diet, and then afterwards you measure their weight loss. Do you see how that's not a real study? It's really got so many things wrong with it. Now we get to the third one. I can randomly pick people, but I test them before and after they get the diet, and then the X is the intervention. Maybe for 1 month they have to stick to the diet. The fourth one, what if there is no pre-testing? I wasn't able to meet these people or weigh them in or anything, but I do have 2 separate groups of people. One gets the diet. You see the other group gets nothing. It's blank. But at the end of a month, we're going to weigh them anyway. Do you see the obvious problem? I don't know how much they weighed before. Maybe they gained weight or lost weight or didn't change. I have no way of knowing. That's why the last 2 have the least amount of error and are the most scientific. This 5th one is a typical research study. I have 2 separate groups of people. I'm going to measure them before and after, but only one group gets the real intervention, whether it's a diet or whether it's medicine or tutoring or whatever. The last one, a Solomon 4-group design. These should be R's here, 4 R's. Hopefully you're picking people at random. Do you see how every possibility is covered? In the first example here, we have a group that gets no pretest and no intervention, but we're still going to measure them, let's say after 1 year. The second one here, we have no pretest, but they still get the intervention, like a year's worth of tutoring, and then we measure their math skills at the end of 1 year or 1 school year. The third one here, we give them the pretest of how well they know math, and then a whole school year's worth of tutoring, and then we test them at the end. And the fourth one, what's going on there? We measure them at the beginning and the end of the school year, but they get no tutoring. Why have four groups? Well, maybe people are just kind of learning anyway, and the tutoring had nothing to do with it. Maybe they're growing older and smarter. Maybe it's because they've seen your test already 9 months ago when the school year started, and maybe that's why they've improved. For whatever the reason, a four-group design can kind of counterbalance that kind of error because it covers all the possibilities. So what will be the answer to the example on the test like this? To just say that a Solomon four-group design covers all the bases, it leaves nothing to chance. So why don't all researchers use the Solomon four-group design? Well, I'll tell you why. It's a lot more work to get four groups of people. It really is. It slows things down. It makes more work for the researcher. If your study is costing you any money, like maybe you have to pay all those tutors, it costs more money, costs more time. So it is a cool type of design for a research study, but it's not often used just because of the time and the expense. Now, do you need a little memory trick for this? Sometimes I learn from students just as much as they learn from me. A student once raised her hand and said, "Was this named after Solomon from the Old Testament, the king who split the baby or threatened to because the two mothers were arguing about whose baby it was? And maybe that's why it's named that, because you're splitting things?" And I'm like, no. That's interesting. Maybe that's a good way to memorize it, but Solomon was the researcher who came up with this design. So that was kind of interesting that a student was thinking creatively like that, and maybe that's why this type of design got its name the way it did. But no, this was really the man, the researcher, the professor, who came up with this design that is intended to minimize, minimize error in an experiment as much as possible. So, real quick recap, error in the experiment. This will get you ready for the next exam, exam number 4, because it's the last section of the reading packet before the exam. An independent variable. What is changing or being manipulated? The dependent variable. What are you measuring at the end? The control group. Expand this a little. The group that gets nothing. But there are 3 ways to give people nothing. You literally give them nothing. They get no tutoring maybe. Or a placebo, like fake sugar or fake medicine, and people think it's real. Or business as usual. You just do what you normally do. The experimental group, they get the independent variable, whether it's the tutoring or the counseling or whatever it is your study's about. Extraneous variables, things that are already in place when you start your experiment and you feel like there's like nothing you can do about it. Gee, I have an after-school program. I didn't expect it to be so many kids of single parents. I guess that makes sense, huh? Because there's nobody else to watch the kid after school. But maybe that ruins my study or adds error to it if I wasn't expecting that to happen. I didn't think there would be so many kids with just one mom or one dad. Confounding. What if something happens during the study? Same thing, an after-school program. What if a kid falls down and gets hurt and you have to stop the study? It ruins the whole study. That can happen. Experimental designs, we just went over this. First one, single group. This should not say random here. That is a mistake in this reading packet. Cross that out. A pre-existing group, a before and after without any observation or pretest. The next one is the same, but you do have a random group of people. The third one is a before and after, but no comparison group, no control group. The fourth one, you don't have any pretest, even though you are comparing one group to another, where one gets the treatment and the other doesn't. The fifth one is a regular, typical experiment, before and after. observations or testing, and one group gets the treatment. And then the last one, the Solomon 4 group design. We spent the most time on that one, didn't we? Well, that's it for this chapter. Take care.